Welcome viewers, in this video we will see the solved problem based on the maximum power transfer theorem contained the DC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Find the value of RL for maximum power delivered to it and also maximum power delivered value. Right? So in the circuit is given. In this, we need to find the RL value, load resistance. The condition given is maximum power is delivered to the load, and also the value of what is the maximum power delivered to the load. We need to find two values, this RL value as well as maximum power delivered to the RL. So the condition clearly given, maximum power is delivered, so we can implement the maximum power transfer theorem to this circuit. So the load terminal is marked as AB. So we have two voltage sources available, 12.5 voltage with internal resistance 0.4 ohm and 1.7 voltage with internal resistance 0.6 ohm, and four resistors are available, 1.2 ohm, 1 ohm, 1.4 ohm and 1.4 ohm. So in order to implement the maximum power transfer theorem, we need to find the Thevenin equivalent circuit. What is Thevenin equivalent circuit? Thevenin equivalent circuit consists of the VTH and RTH, voltage source in series with the resistance. What is VTH? It is the open circuit voltage. The load terminal is open circuited and voltage across the AB is nothing but VTH. What is RTH? Is the resistance across the AB by removing the voltage and current source. So by removing voltage and current source, the resistor available across AB is nothing but RTH. So this RTH is nothing but system resistance, internal resistance, right? So this we have internal resistance. So based on the maximum power transfer theorem, this internal resistance is equal to load resistance. So by after calculating Thevenin equivalent circuit, it will become easier. We have voltage source, only one voltage source. The complicated circuit is reduced into only one voltage source and only one resistance. That is nothing but a internal resistance. Based on the statement, these two are equal. So we can get the simplified circuit. We can easily calculate the R value. R value is nothing but RTH. And maximum power delivered to the load formula is available. VTH divided by 4 into RTH. V square by R. The formula is available. So by finding Thevenin equivalent circuit, we can easily calculate the value of R as well as power delivered to the R, because this is the system internal resistance. Condition is internal resistance equal to load resistance. Right. Now we'll go for Thevenin equivalent circuit. First we will find the Thevenin. First we will find Thevenin. To find Thevenin, disconnect the R. The load resistor is open circuited, right? So now we need to find the voltage across AB, that is nothing but VTH. VTH is nothing but voltage across AB by making open circuit, right? How to find this VTH? That is, first we will find the current. This VTH is nothing but VAB, voltage across AB. Either this side you can calculate, because voltage across AB equal to voltage drop across this side or that side, either this side or that side. For that we need first find the current, because this is already one voltage source is available. Then here two resistors are available. Some of the voltage will be dropped across. So from the voltage source, from this voltage value, if we subtract the voltage drop across these two resistors, we will get AB. VAB. Similarly, from this voltage source, if we subtract the voltage drop across these two resistors, we will get VAB or VTH. Either side we can use. In both the cases we need current value. So what is the current I? I equal to V by R. What is the V? Voltage? Two voltage sources available, 12.5 and 1.7. So the difference between these two is the total voltage, 12.5 minus 1.7. divided by the total resistance. What are the resistance available? This is the internal resistance of the voltage source, 0.4, 1.2, 1. Internal resistance of second voltage source, 0.6, 1.4 and 1.4. Right? 1, 2, 3, 4, 5, 6 resistors are available. All are added. 1, 2, 3, 4, 5, 6. So after simplification we got 1.8 ampere. Right? The current flowing through the circuit is 1.5 ampere. Now we will find the Thevenin. V Thevenin equal to VAB. So we calculated from that side. We are not, this side also we can calculate. So 1.7 voltage is available. 1.7 voltage is available. See the current value, current is flowing downwards, that is positive terminal to negative terminal. So drop in voltage minus 1.7. Minus, we have to subtract the drop across these two voltage sources. Voltage drop is V equal to I into R. I is 1.8 ampere. The R value is this 1 ohm and 1.4 ohm as well as this 0.6 ohm. Internal resistance of the voltage source. There also some voltage will be dropped. So 1 plus 0.6 plus 0.4. Right? So this is the total voltage source available. From there we are subtracting the voltage drop across the resistor. Voltage drop across the resistor is V equal to I into R. I value is 1.8. R value is these three. 1 plus 0.6 plus 1.4. Now we will find the value. So the simplified value equal to VTH equal to VAB equal to minus 1.7 minus 1.8 current. This is the total resistance into 3. After simplification we got minus 7.1. Both are negative, minus 7.1 voltage. So V Thevenin equal to minus 7.1 voltage. Now we will find the R Thevenin value. R Thevenin is nothing but the resistor across AB. By removing the voltage source, voltage and current source. Here we have two voltage sources available, that is removed. If you remove the voltage source, is short circuit. By removing current source is open circuit. So here one voltage source, here one voltage source, both are removed, but that contain the internal resistance, that is calculated, that is added 0.4 ohm and 0.6 ohm. Right? Both are taken into account. Sometimes the problem not given internal resistance, but in this problem internal resistance are given. So that is calculated. So we need to find what is the resistor across AB. So this side one circuit is available. This side one circuit is available. So current at this point is divided. It means these two are parallel. The same current is flowing through all three resistors. Same current is flowing through all three resistors. That means these three resistors are connected in series. These three resistors are connected in series. Then both are parallel. So that is given here. 1.2 plus 0.4, 1.6 plus 1.4, 3 ohm. 1 ohm plus 0.6, 1.6 plus 1.4 is another 3 ohm. Right? So this branch is connected in series 3 ohm. This branch is connected in series 3 ohm. Both are in parallel. Right? So RTH RAB equal to R1 into R2 divided by R1 plus R2. 3 into 3 divided by 3 plus 3. That is 9 by 6. It is 1.5 ohm. If both resistors are equal, we will get half of the value, 1.5. Directly also you can write. 3 ohm and 3 ohm connected in parallel mean half of the value, 1.5 ohm. Now we got the V Thevenin value as well as R Thevenin value. We can draw the Thevenin equivalent circuit. So this is the Thevenin equivalent circuit. VTH is minus 1.7 minus 7.1 voltage. RTH is 1.5 ohm. This is the load terminal RL. So based on the condition what is given, this RTH equal to RL. So RL value is nothing but 1.5 ohm. Right? That is the advantage of this Thevenin equivalent circuit. The complicated circuit is simplified with a single voltage source and resistance. This resistance is equal to RL based on the maximum power transfer theorem. Then how to find the maximum power transfer? According to the statement of maximum power transfer theorem, the value of RL for maximum power to transfer is RTH equal to RL. Both are equal. That is 2.1 ohm. And the maximum power transfer formula is available. VTH square divided by 4RL. This is the formula to find the maximum power transfer under the condition. This RL is nothing but RTH. Both are equal. So VTH square divided by 4RTH. That is equal to 7.1 square divided by 4 into 1.5. That is 8.4 watts. So maximum power delivered to the load is 8.4 watts. So we calculated load resistance value, also maximum power delivered to the load. So in this problem, we discussed the maximum power delivered to the load and maximum the RL value by using maximum power transfer theorem. Further, we calculated the Thevenin equivalent circuit, VTH and RTH. This RTH is equal to RL, that is the advantage, and also maximum power is calculated from this formula. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.